Hey guys, so lesson 5, 2 graphing stories. This is the last section for topic A. This will be your second quiz. So really what we're doing is we're actually solving systems in this lesson. Later in the modules, probably like module 4, we're going to be solving systems of linear equations and systems of quadratic equations. But right now we're really just talking about what happens when two graphs intersect. Okay? So consider this. Maya and Earl live at opposite ends of the hallway in their apartment. Their doors are 50 feet apart. Each starts at his or her own door and walks at a steady pace towards each other and stops when they meet. What would their graphing stories look like if we put them on the same graph? When the two people meet in the hallway, what would be happening on the graph? Sketch a graph that shows the distance from Maya's door. So we're showing the distance from Maya's door. So we're going to put distance from
Mr. Denavasilis, to the office, please.
Maya.
Mr. Denavasilis.
Well, take 2. Distance from Maya's. Okay, so we've got two things that are happening. We have distance and we have each starts at his or her own door in a steady pace and time. Okay, so we're going to have Maya's graph, which is here, because we know these are 50 feet apart. Okay, so let's call that 45, 40, 35, 30, 25, 20, 15, 10, 5. So, then we'll go something like this. Doesn't really matter. We'll call it 5 seconds, 10 seconds, 15, 20, 25. So Maya is walking at a steady pace, and then she hits 50 feet. If Earl lives at the opposite end of the hallway, and they're 50 feet apart, and he starts walking at a steady pace, where are they going to meet? Well, here's where Earl starts, 50 feet away. There's his steady pace. So they're meeting somewhere at like 12 and a half, and should be a steady pace, so we're going to call that 25, just because I can, because I know if it's a steady pace, they're going to meet at 25 feet. So what's really happening is they are meeting halfway from the time that they're walking at an ordered pair of 12 and a half, comma 25. And what does that mean? That means that after 12 and a half seconds, they meet 25 feet in the middle of the hallway. Okay? But that's just showing how far they're traveling. Where it intersects, even though it's two graphs, where it intersects is going to be our most pertinent information. Okay, moving on. So, this is going to be the first time that I've asked you to do something at home that you're going to bring back in. Okay? So, you are doing exploratory challenge 1, 2, 3, and 4. Okay? I am not going to do this for you. So you're going to need to go online, type this in, watch the video, graph, answer, answer, and answer number 4. Okay? That's on you. Okay, but this one is a little bit more important. Duke starts at the base of a ramp and walks up it at a constant rate. His elevation increases by 3 feet every second. Just as Duke starts walking up the ramp, Shirley starts at the top of the same 25-foot high ramp and begins walking down the ramp at a constant rate of 2 seconds every second, or 2 feet every second. So I should have a much nicer graph in here, but I don't, so I'm going to make the graph. And hopefully I can make it perfect. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, there's 26. So now we know 25 feet, so this is distance in feet. This is going to be time in seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So, a couple things that you need to know. This graph is not going to be perfect. My answer might be a little bit off from what the book has. Why? Because it's not done on a perfectly made graph. I'm going to try to make it as perfect as possible. So Duke starts at the base. He's starting here. This is going to be Duke's graph.
Teachers, please be sure to check your key today and make sure it unlocks your room. Check your key and let us know.
If you're wondering, I haven't got
that
the key yet.
Thank you.
So his elevation increases by 3 feet every second. So he goes up 3, 1 second. 4, 5, 6, 1 second. 7, 8, 9, 1 second. Okay, so this is what Duke's graph is looking like. Starting at 0, because that's where he's at, and then he's making it go up and up and up at a constant rate of 2 feet per second. That constant rate of 2 feet per second is actually the slope. 2 per 1, that's our slope. Okay, then we've got Shirley, who's starting at the top of this ramp at 25 feet. Hers is down 2 feet, 1, 2, over the 1, down 1, 2, over the 1, down 1, 2, over the 1. So there's Shirley's. Let's see if I can make Shirley's graph here. Hopefully it works all right. Yeah, pretty good. Oh, except for that part. Okay. So, what are the sketch the graph. So now I've got Duke and Shirley. Really, what should I do is I should write Duke, I should write Shirley, and I should have an elevation versus time heading. But based off of what we're doing, this is all I need. Remember, the most important thing about these is this point of intersection. Okay? What are the coordinates of the point of intersection of the two graphs? At what time do Duke and Shirley pass each other? So the point of intersection is 1, 2, 3, 4, 5. And it's right around 15. So my ordered pair is 5, 15. That's the coordinates of the point of intersection. At what time do Duke and Shirley pass each other? At 15 seconds. Okay? That's important. Now, there is another question. Question 7 says, and if you keep going down, I'm going to leave this there. Question 7 says, write down the equation of the line that represents Duke's motion as he moves up the ramp. Okay, this is important. We know that Duke has a y-intercept of 0. Okay? Duke has a y-intercept of 0 because he's starting at the bottom. We know that his slope is up 3 feet for every 1 second. So he's going up 3 over 1. So can we write Duke's equation? Based off of that basic stuff that we did beforehand, we can say that Duke's is y equals 3x plus 0, or just y equals 3x. Well, how are we going to do Shirley's? Now Shirley's is a little bit different. So what's happening with Shirley? Well, Shirley's starting off at a y-intercept of a positive 25. But what's the difference between Shirley's line and Duke's line? Well, Shirley's line is going downhill. So if it's going downhill, that means my slope is going to be negative 2. Why is it 2? Because it's going 2 feet per second. So now we can say Shirley's is y equals negative 2x plus 25. So I've now got the equation for both Duke and Shirley. But what can I do now? Well, here was my guesstimate based off of my graph. For this point to work, that means it has to work for both equations. So when I have Duke's y equals 3x, I take my x value and I substitute it in, which is 5. I take my y value and I substitute it in. Does it work for this equation? 15 equals 3 times 5, 15 equals 15. This point works when I substitute it into Duke's equation. But what about Shirley's? So we've got y equals negative 2x plus 25. My x value is still 5. Y equals negative 2 times 5 plus 25. My y value is 15. So now we have 15 equals negative 2 times 5 plus 25. So if I'm solving this or simplifying it, that gives me 15 equals negative 10 plus 25. That's positive 15 equals positive 15. Therefore, 5 comma 15 works for both of them. So what does that mean to me? That means that Duke and Shirley pass in 5 seconds at 15 feet. Okay? So that works for both. The intersection point of the graph of two equations is the ordered pair, and it's a solution to both equations. Okay? Does it always have to be linear? No. You're going to see piecewise functions. You're going to see quadratics. You're going to see lots of this. This right here is called the system of a linear equation, and we will be doing a bunch of those later on. Right
As
now,
long
as
as you
long as
can
you graph it and find your point, you're going to be able to do this. Again, the intersection is the most important thing. So, you're going to have a quiz on lessons 1, lesson 2, lesson 4, lesson 5. Okay? So you might want to go back, rewatch those videos, ask for any help. Quiz the next time you come in. Woo-hoo!